Okay, so I trust that you guys got some time to do the questions. Okay, so this is on 1.3, yeah? So you can go to that page on 1.3. Uh, for question 1, how can you tell if something is pure? Now, previously in chromatography, we learned that for something to be pure, there can only be one spot, right? One spot on the chromatogram. So after you do the experiment, at the end of the day, there will only be one singular spot. Now, if there's more than one spot, okay, let's say if I have another spot, I'm just going to use another color for that. Let's choose a rainbow color, okay, all the way here, okay, then this will be an impure substance, okay, because there's two spots on the chromatogram. But apart from using chromatography, there's actually another way to determine purity, and that's using melting and boiling points. Okay, so pure substance will always melt and boil at a fixed temperature. For example, water's melting point is 0 degrees Celsius, and water's boiling point is also 100 degrees Celsius. Fixed one, cannot change one, okay, unless you add impurities inside. So let's say you add some salt inside water, okay, then maybe instead of 100 degrees Celsius, it will start to boil from 101 degrees Celsius to, let's say, 105 degrees Celsius. Okay, it will boil over a range of temperatures. Can so for question 1, how can you tell if something is pure? It will have to boil at a fixed temperature. And to prove that ACD is wrong, okay, clear and colorless, it doesn't really tell you whether or not it is pure or not. For example, you can have salt and water. Salt and water also clear and colorless, one, okay, but it's not pure. Okay, it's a mixture. Burning in oxygen, there, actually anything can also burn in oxygen, right? Correct or not? You throw your friend into the fire, your friend also will burn, right? Okay, or you throw your PLD or your school notes or anything into the fire, they also burn. Okay, so it doesn't tell you anything. And whether or not you can use something as a solvent, it also doesn't tell you about the purity. In fact, in real life, a lot of the solvents that we use, for example, nail polish remover, it's a mixture. Okay, usually it's a mixture. So D is also not the answer. And for next one, also asking you, how do you tell if something is pure? Let's go and find the answer, okay? So every time you see a question like that, how can you know if something is pure? Only got two ways, okay? It's either one spot on the chromatogram, or melt and boil at fixed temperature. Okay? If it is more than one, okay, if it's more than one, then it's impure already. If it doesn't melt and boil at fixed temperature, means it melts and boil over a range of temperature, then it's also impure already. Okay, so let's go and find that answer. Okay, use your eyes and go and zoom in to the answer here. Okay, it freezes exactly at 0 degrees Celsius, and it boils exactly at 100 degrees Celsius. Now you might be asking me, just now Mr. Zhang say pure substance must melt and boil at 100 degrees Celsius, correct or not? Melt and boil. But in this case, the question used the word freeze. But does it matter or not? Doesn't, right? Okay, melting and freezing is the same thing, right? From solid, it's not the same thing, okay, but it happens at the same temperature. Okay, for example, from solid to liquid is melting, right? Melting. And then from liquid to solid, it's freezing. So it doesn't matter if you're melting or freezing. In the case of water, for example, it will always melt and freeze at 0 degrees Celsius. Okay? I let you go and think. So if for B, if something melts and boil over a range of temperature, okay, what is it? Okay, what is this? You guys can tell me in the next lesson. Okay. But of course you can just tell Mr. Zhang. Okay. Just go and, or you can see me, or you can see me in school, you can just stop me. Hey Mr. Zhang, I know. What is the thing that melts and boils at over a range of temperature? Okay. Okay, now you can go and try the next section, okay, 1.4. Uh, but of course, you can go and read the items on the SLS first.